All right, guys, so we're starting the next chapter today, which is chapter 4. So what we did previously, matrices were a part of the, I called it GB chapter 4 green book, because the old textbooks that we used to have did go into matrices a little bit more in depth than the books that we, well, aren't technically the old books, the big idea math books went into. So did that just so that we could see a little bit more matrices. But our next chapter is going to be over polynomial functions. Now, quadratics are a type of polynomial function. It's these higher degree functions. Because a polynomial is just a group or sum of monomials. Now, this here is the general form of any polynomial function that we could write ever. A sub n minus 1, a sub 1, a sub 0. All of those are just numbers. It's just a number. It could be any number. It could be 1, 7, 1/2, any real number. And we just signify it as a. Our x to the n, x to the 7th, x to the 6th. These are just, n is just a number. Now, these here are 5 different types of common polynomial functions. The first one, when the degree is 0, we call it the constant function because we have just a number. We don't have a variable. We could write 1x to the 0. Constant. If the degree is 1, it would be a linear function because 5 to the x, the only variable we have is x. And realistically, all right, guys, up here, x is to the first power, so it's a degree 1. The one that we've spent all of chapters 2 and 3 on, quadratics, is a degree 2, and the biggest exponent attached to a variable is 2, so it is a quadratic. Our next one is a cubic. We call it a cubic because the degree is 3. The biggest exponent attached to a variable is 3. Next one that we have is quartic. And we call it quartic because it is a degree 4. Biggest variable attached to an exponent is 4. Questions on how we can identify degree and type. Yes, and I don't think it'll come up, but 5 I think is quintic. But that's my assumption. I need to look that up. But main types that we're going to have are 1 through 4, 0 through 4. Now there is some more information before we start looking at these here. And that's this here. Standard form. If we write a polynomial in standard form, we're going to write it from biggest exponent, variable to biggest exponent, to least, which is normally going to be whichever one has the biggest exponent to our constant term, our term without a variable. That's all standard form is. Leading coefficient is the number in front of the variable with the biggest exponent. That's all the leading coefficient is. All the numbers in front of variables are coefficients, but the leading coefficient is the one in front of the variable with the biggest exponent. So, any questions on this so far? Okay. Next thing we need to do is define what a polynomial is. And there's lots of different ways we can try to define it and explain it. But I think it's going to be easier to explain what it is not than try to explain everything that it is. And the first thing that a polynomial function cannot have is that its exponents cannot be negative. We cannot have a negative exponent attached to a variable. We could have 2 to the negative 1 if we wanted, but the negative exponent cannot be attached to a variable. So we cannot have x to the negative 2. Next thing is that we cannot have fractional exponents attached to our variables. And again, these are mainly attached to the variables. Exponents cannot be fractions on our variables, so we can't have x to the 2/3. We can have 1 to the 2/3 or 2 to the 2/3. We just cannot have our variables with those fractional exponents. Exponents aren't variables. We can't have x to the y. We really can't even have 2 to the x. Either one of these. And part of the reason for this is actually 2 to the x is not a polynomial. It's actually considered an exponential. Questions on this so far? Variables aren't inside of radicals. Doesn't matter what kind of radical we have. We can't take the cubed root of x, square root of x. The variable cannot be inside the radical. It can be multiplied by the square root of 2, but the variable itself cannot be inside the radical. Because those are our radical functions. We can't have variables aren't being multiplied together, specifically different variables. We can't have x times y. X times x is fine because x times x is just x squared. We can't have 2 different variables being multiplied together. We can't have x times y. And lastly, we can't have variables in the bottom of a fraction. We can't have variables in the bottom of a fraction. Because if we get any one of these here, any one of these shows up, then it is not a polynomial function. And at this point here, we're not going to have to try to name it. We're just going to say, no, it's not a polynomial function. All right. Questions on this so far? Are you ready for the first example? So we'll look at A here. So first, we need to decide whether each is a polynomial function. If it is, we want to write it in standard form, state the degree, type, and leading coefficient. So if we look at A, f of x equals negative 2x cubed plus 5x plus 8. So we're going to go through all these here. Is there a negative exponent attached to one of the variables? No. Is there a fractional exponent attached to one of the variables? Well, no. Okay. Exponents aren't variables. Well, no, there's no variables. Exponents. Do we have a variable inside of a radical? Do we have 2 different variables being multiplied together? Do we have a variable in the bottom of a fraction? No. So is this a polynomial function? Yes. Okay. So now we move on. We want to write it in standard form. So what's the variable with the biggest exponent? Negative 2x to the third. Then we would go to square. We'd look for x squared terms. There aren't any, so we move on to our x terms. Plus 5x in our constant term, which is 8. So incidentally, this was already written in standard form. We really didn't have to do anything to it to change it. Now the degree. So what is our biggest exponent attached to a variable? 3, so the degree is 3. And the type would be cubic. Cubic, leading coefficient. The number in front of the variable with the biggest exponent is almost -2, because we need the sign 2. It'd be -2. Questions on how we did A? We're going to jump down to C. We'll come to B, back to B in a second, but C, is this a polynomial function? Why is it not? We have this x to the -1, so it's not a polynomial. We can go in a U shape. D is not a polynomial function because 3 to the x, we have a variable and an exponent. Yes, not a polynomial. Because 3 to the x, since it's not a polynomial, we're not going to state degree, leading coefficient, type, or write in standard form. It's not a polynomial function. Really, this 3 to the x is exponential. It's an exponential function. Let's look at B. Is B a polynomial function? Yeah. Yes. Now, it might be tempting to say no because our square root of 2 times x to the 4th. Yeah, since the x to the 4th is outside the radical, it is still a polynomial function. Yes, this is a polynomial function. Now, this is not written in standard form because our variable with the biggest exponent is our square root of 2 times x to the 4th. Now, we do need to make sure when we rewrite this that the x to the 4th does not get inside the radical. It is outside the radical. Our next one would be what? Minus 0.8 x to the 3rd. We don't have a squared term. We don't have an x term. We just have minus 12. Now, what's our degree? 4, which would be a quartic. And the leading coefficient would be? So the number in front of the variable with the biggest exponent, which is?
2. Well,
radical 2. Square root of 2. Radical 2. That's it for this part here. We'll look at 2 more. Let's look at 1. Is 1 a polynomial function? Yeah. Yeah, we could go through the whole checklist. None of them show up. So yes, this is a quadrant. This is a polynomial function. I'm wanting to say the type. Is it written in standard form? No. So what would go first? Negative 1.6x squared. Then negative 5x plus 7. The degree is 2, which is a quadratic. Yeah, it's a quadratic. And the leading coefficient is negative 1.6. Questions on this here? We good? Yeah. How about number 2? Is it a polynomial function? No. No. Because of our x to the negative 2, it is not a polynomial function. And since it's not a polynomial function, we don't have degree. We're not going to say degree, leading coefficient type, because it's not a polynomial function. Questions on this here? Are you ready for the next bit? All right, we're going to look at the next problem. You all ready? Evaluate f of x equals 2x to the fourth minus 8x squared plus 5x minus 7 when x is equal to 3. And again, when we evaluate for a number, all we're going to do is substitute. We're going to plug 3 in for every x on this here. We're just plugging 3 in. Now, there's two ways we can do this. One is we can do this by hand. The other way, we can type this entire thing into the calculator, and it'll tell us exactly what the answer is. I don't know why I was thinking cubed. That's it. We don't have to do it by hand, because if you want to type that whole thing in exactly as it is with parentheses around our number we're plugging in, that will give us our answer. Questions on this here? Because if we look at this next one here where x is 4, well, we would say negative 2 parentheses 4, close parentheses to the fourth, plus 6 parentheses 4 to the third minus 3 times 4 plus 11. And again, at this point here, all we've got to do is type it in exactly as we have it and get our answer. Yes. 64 and 64 is 2, so that'd be 256. Like 12. You all said negative 129? Questions on how we plug these in and got our answer? I think we feel pretty comfortable with this here, yes? The only ones we do have to be careful on is if the number we're plugging in is negative, because we definitely need the parentheses around it. Now, for the most part here, x to the fifth and negative 6x isn't going to cause an issue if you don't have parentheses or do. The x to the fourth is one that's going to cause problems, because if you put the parentheses, we'd have negative 2 to the fourth. Well, 2 to the fourth is 32. Then the negative would make it negative 32. If you don't put the parentheses, it'll see it as negative 2 to the fourth. 2 to the fourth is 32. The negative makes a positive. It's going to tell you that it's positive 32, which is a different answer entirely. So, again, when we have these negatives for x, make sure you're putting them in parentheses, because we should type it in as 3 parentheses negative 2 to the fifth, minus 2 parentheses negative 2 to the fourth, minus 6 times negative 2 plus 10, because this is going to be 3 times negative 64 minus 32 plus 12 plus 10. 2, carry the 1, 192 minus 32 plus 22. We can say 192 minus 10. I don't think that's right. Yeah, it should be negative 90. Yep. Yep. 2, 4, 8, 16. Ah, that's why. This should be 32. And that should be 16. That's why. I did 2 to the 6th instead of 2 to the 5th. 6, negative 96, minus 16, plus 22, negative 96, plus 6, which is indeed negative 90. Yeah, I did 2 to the 5th instead of 2 to the, or 2 to the 6th instead of 2 to the 5th. Questions on this here? All right. Last thing we're talking about today is in behavior. Last thing we're talking about today is in behavior. Now, in behavior is a nice thing to know. Now, quadratics, we've talked about them so far. Quadratics are degree 2, and they open one of two ways. They either open up or down. They either opened up or down, which means as we increase to the left and right, the ends of it either are going to go to positive infinity. Positive infinity, they're both going to go up, or they're both going to go down. Now, interestingly enough, if the degree is even, because quadratics are even, or if it's degree 4, 6, 8, 10, 14, 16, and continuing on even, what's in the middle is going to change depending on the function and how we have it written. But eventually, if you go out far enough, left and right, with even functions, they're both going to end up going up or down. They're both going to go in the same direction. And we describe that in behavior based off degree and leading coefficient. If the degree is even and the leading coefficient is positive, we're saying that eventually the two ends of the function are both going to go up. So we'd say the in behavior would be these two pieces here, that f of x approaches positive infinity. That arrow approaches positive infinity as x approaches negative infinity. As we plug in smaller and smaller values of x, the y value, the function is going to equal a bigger and bigger positive number. F of x approaches positive infinity as x approaches positive infinity. As we plug in bigger and bigger numbers, the function is going to continue to go up. Degree is even and the leading coefficient is negative, so eventually they're both going to go down. So f of x approaches negative infinity as x approaches negative infinity. Or f of x approaches negative infinity as x approaches negative infinity. Odd functions are going to go in opposite directions. Eventually they're going to go in opposite directions. The middle can change, it's going to go up, down, but eventually the two endpoints are going to go in negative directions one way or the other. Now this seems like a lot of information, there's a lot to it, but there's actually not as much as you might think. So if we look at this first one, there's two pieces of information I need to get from it to be able to determine the end behavior. First piece of information we need is the degree. And the degree is indeed 4. Now it is a quartic, but more specifically, this is an even function. Because 4 is even, so we would consider it even. Leading coefficient is negative 0.5, and the piece that we're grabbing from this is that it is negative. Because within behavior, it's either odd or even, positive or negative. So it's even and negative. So these two pieces of information are our answers. So we'd say exactly our end behavior, f of x approaches negative infinity as x approaches negative infinity. And f of x approaches negative infinity as x approaches positive infinity. Focus up here, guys. And all this is saying is that the x values are eventually going to go down. They're going to be heading down. questions on what we did here? If really we find the degree and leading coefficient and match it to its part on the chart. Are you ready for the next one? Let's look at the next one. So here, the degree is 3, which would be odd. And the leading coefficient is negative 0.3, which is negative. So again, we're going to go back to the chart, and we're looking for odd and negative. Now, according to the chart, f of x approaches negative infinity. Let's see here. No, infinity as x approaches negative infinity. And f of x approaches negative infinity as x approaches positive infinity. Questions on any of this here? We feel good within behavior. All right. That's it. Yes, there are 2 error detection. Yes, there are 2 problems with error detection, but they are both based off of determining if it's a polynomial, stating degree, leading coefficient. Yes.